Welcome to part 3 of chapter 14, Water Resources. We're going to start today with groundwater. We just finished up with surface water. Looking at the United States, and I know we have talked about this in class, but looking at the United States, we see that we've got about a third to a half of the United States looking at water deprivation or depletion of aquifers. Notice in Florida and Georgia, it's a moderate, and if we go out to Kansas, Iowa, Nebraska, we're starting to, in central Texas and Oklahoma, you're seeing some critical issues there. Central California, and we've talked a little bit about California's woes over the past few years with the drought and the 25% reduction in use of water that's just come about this year in last year, 2015. Let's look at this Ogallala Aquifer. It supplies all of the Central Plains or High Plains states with water. The people there for drinking water, but mostly for agriculture. It has been used for agriculture. They're plains state. This is a grasslands area, so they don't get much water. 10 to 20 inches of water a year, or precipitation, whether that comes in water, rain or snow. So, historically, it's been a grasslands. It's not an area where trees can grow, and it's really not an area where most crops can grow. Most of the farming, though, that's done out there, corn and wheat products, both drought tolerant to some extent, but everything is irrigated in this area. What we're finding is that because we have not had normal rainfalls in those areas, that the aquifers are going dry. So that's an issue that continues to plague us. You have to think about it not just for drinking water, but for food source as well. We've got enough water on the planet, but most of the distribution is, you have high areas of distribution, and it's not always where the people are. And so we use some techniques in different areas to get the water to people, such as damming, desalinization so that they can use ocean water, and also diversion techniques. But when you look at some of these countries in Africa, especially that are very poor countries or war-ridden countries, they have problems obtaining good, clean water. We don't even think about it. We go to the water fountain and get a drink, and we don't have to worry that there's parasites in there or bacteria that's going to hurt us. And those people do. They have very limited access to clean water, and it's very expensive for them at this time. And then as we go through climate change and more people in the world, we're utilizing more water, and climate change is changing where precipitation patterns happen, then water can be more of an issue not just in those developing countries, but also in our country as well, as you saw with the aquifers. Potential issues that you see, and we're already seeing it. Reduced snowfall. And if you don't have snowfall in like the western United States, That's where that snow melt is, where they get most of their surface water, and they don't have enough in their reservoirs for them to utilize it at the levels they have been using. Also, with climate change, we're expected to see a sea level rise, and we talked about the saltwater intrusion if we use too much of our aquifer. Well, what happens if sea level rise gets higher than the water table? We're going to have saltwater intrusion into our wells. That's something that Florida, South Florida, is going to have to look at and possibly be ready for. I'm giving you a few minutes to write this down. We've discussed this within the lecture that we've already had in class. It's hard enough, or it has been, in the United States to share water. You guys don't know anything about this because it happened a long time before you were born. But as people were moving west and there were no water regulations whatsoever, and the west is primarily dry except for the snowfall. So ranchers and settlers would dam off streams and rivers and utilize the water. Then the people down below them would get limited access to the water, or maybe not water at all. Water keeps you alive. It helps you grow crops. People got killed in the United States over fighting for water. As water becomes more depleted in the world, and there are more people who need water, we're anticipating that might be an issue later on. So when we look at areas where we've got two countries sharing water or multiple countries sharing water, they've had to come up with some way to cooperate. And it's very hard when you're talking about different governments. Even in the United States, it was hard to come up with a good plan with the Colorado River or any of the rivers out west. And now there's no centralized government. You actually have, if you look at this one, the Rhine River, you're working with Germany, Belgium, the Netherlands, Switzerland, France, all in Austria, all utilizing that Rhine River. And what was happening as the Rhine River flows to the North Sea, so it's actually flowing north. And what was happening is countries downriver were polluting it, and then the countries close to the North Sea, they would have to try to clean it because it was so dirty that they couldn't use it for drinking water. It was full of chemicals. It was very turbid. And they said, hey, you guys are the ones doing this. We shouldn't have to suffer. And it took a lot of cooperation. But the European countries were able to cooperate, and for the most part, the water is much cleaner in the Netherlands now, and they do have some availability to it. This is the Aral Sea. This is just east of the Caspian Sea. It is a saltwater sea that is completely landlocked. What you're seeing is 1976, 2008. And basically what has happened, this didn't even start in 1976. It's a lot smaller than it was pre or early 1900s. The use of the water going into here. There were two major rivers that go into here, and the Russian government decided to divert those rivers to use for agricultural purposes, to try to grow crops in the desert, which did not work very well. And basically what they've got going on, the white that you see in the picture on the right is salt. So it increased in salinity levels 1,000 times. So virtually nothing can live in that, change the ecosystem. They have some groundwater that goes into there, but most of it came from those two rivers, and the rivers being diverted and being used, we had, as you can see, just like Mono Lake, which we talked about in class, lower levels of water. You're going to have a higher rate of evaporation. Therefore, that salt is going to increase. The salt content of the remaining water will increase. So not only do we have the fresh water being taken out, but we also have the higher rate of evaporation. Two rivers, the Jordan and the Nile. The Jordan River, I'm sure you know that the Israelis and Palestinians don't get along very well. And this is a river that they both use for water. And it is a desert area, so agriculture as well as municipal uses. So very, very hard to come up with water supply agreement between the Israelis and Palestinians. Also, the Jordanians use this river as well. Possibly as climate change takes effect and that water in that river becomes less, there could be major issues just because of the volatility of that area in the first place. Nile River is also a river under discussion. This runs through Africa, and Egypt uses most of it, and it flows down into Egypt from the Sudan. But as other African countries upriver start using it more for agriculture, then Egypt's not going to get as much, or have as much flow coming to them. They'll need to create some kind of water use pact with the other countries in Africa. And those are very, very volatile countries as well. Therefore, it looks like that might be an area where there's actual fighting over water. How do we maintain high quality water and maintain a supply? There's three different facets to this: dams, reservoirs, water diversion projects, and desalination. Dams and reservoirs allow us to have a full-time, year-round, steady supply of water. Water diversion projects allow us to move water to areas where we need, and those projects have been going on since the Romans and the Greeks. Desalination allows us to use water out of the ocean. Very expensive, but it is the primary source of drinking water in Saudi Arabia. Saudi Arabia has lots of oil and gas, but they don't have any fresh water. Okay, dams and reservoirs. And we've talked about dams already and how they're a major no-no in the United States. In fact, we're tearing some down. But benefits. And there are benefits. Water supply and a regulated flow downstream, which, if the river is getting snowmelt, and you have a lot of snowmelt in the spring, obviously, It doesn't allow the river then to flood areas downstream during the springtime, holds the water back in the dam, and then can provide flow downstream all the way through the fall. Because what happens is you have high, if there's no dam, you have high flow in the spring, so you have floods, and then when you get to the end of the summer, you almost don't have any water downstream. So this regulates the flow, so in that, it's good. Also, dams can be used to generate electricity. Now, not all dams are used for electricity. Not all dams are large enough to provide that, but we have several in the United States that do. And Tennessee has power generated dams, and the Tennessee Valley Authority runs those. Hoover Dam out in the west, and Coolidge Dam out in Washington State on the Columbia River. Those are big areas for dams that provide hydropower. And having the reservoirs provide recreational areas. People can boat, fish, and do multiple aquatic activities. Disadvantages are enormous. It is ecosystem devastation. They alter the ecosystem. Terrestrial ecosystem is forever flooded, so you can't use it. Reduces sediment load, which means that the water backs up in the reservoir behind the dam, then it slows it down and it starts to drop out particulate matter. That particulate matter is very important for fish habitat, and I've got slides in here to show you that. Okay, this is just showing a Glen Canyon Dam and how the flow has regulated. Okay, now in A, and this is all in your book, so you can look at it in your book too. I want you to notice the sandbars. See how the river's flowing around the curve? And basically what has happened, when the water hits a curve, just like your car, when you drive or turn, you slow down. So right after that, it allows for sediment deposition. This allows then for areas in this fast-moving, chilly water, it's fish habitat. This is where they lay their eggs, they take a nap. The young are able to be in slower water until they get bigger. Notice after, go to B, dam construction, the sandbars, because we don't have the ebb and flow, we don't have fast moving waters and slow moving waters, it erodes the sandbar away. We just have a constant flow, and it's not slow enough at certain times to drop that particulate matter. So we don't have those more shallow hidey holes, as a lot of fishermen call them, for the fish to spawn and to rest. Then in C, basically what we've got going on is they'll let a lot of water out if it's getting to, and they'll let the water out, see how turbid it becomes because it's really flowing, and then what they'll do is slow it down after they get the water good and turbid, slow it down, and now we've got an increase in sandbars. Now, if you look at the sandbars, if you look at A and D, it's not exactly the same as it was naturally, but we have learned to do this so that the fish habitat has been maintained. And so that's a good thing. Sandbars are not exactly the same shape, but if you look kind of up the canyon a little bit, we still have some major sandbars that they can use. So we learned that we can't just have the same flow all the time, that we have to stir the water up a little bit so that we can get sediments. And so management of these dams is very, very important to aquatic habitat. This is the big issue with dams out west, and it's trying to maintain salmon populations. Salmon are endangered species. We spend billions, that's with a B, billions of dollars to protect these fish every year. And I know somebody was looking them up in class the other day, and you saw the salmon cannons. So this is actually a fish ladder. And these salmon basically are born in freshwater ecosystems. They travel out to the ocean as juveniles. They live in saltwater for up to 6 years. Then when they become full-fledged adults, they go back into the river and they swim upstream to get back to where they were hatched. And they lay their eggs and then they die. Salmon fishing is a huge, huge sports industry. Salmon for food on your table, huge industry. And between the dams and overfishing, it hasn't just been the dams, but overfishing, salmon have become endangered. And so most of the salmon you see in your grocery store, it's going to be farmed. So we'll talk about fish farming later. When these go through the dams, they become injured. It's very hard on them. Fish, let's just go with a hydroelectric dam. The water that goes through the turbines, and those turbines are like fan blades, huge fan blades, just those can kill the fish. Also, when water goes through the friction of those turbines, the water gets very hot. These fish are used to very cold water. So you have thermal pollution that also, the thermal pollution doesn't affect the adults as much as it affects the juveniles, but it does affect them. Okay? Thermal pollution not is just at the end of the dam, because that hot water is very hot, so it affects it miles down the stream. Okay, we need to look at two things here. Just the heat at the point of the dam and changing their body temperature very, very fast. So that's why juveniles don't do well with it. Also, the amount of oxygen that's available. Cold water holds more oxygen than hot water. So they're going into oxygen deprivation as well. So those two things with thermal pollution. These ladders help get them around the dam and shove them out so they don't have to go through those turbines. They work very well. This is the top of the dam, and you can't see any fish there, but you can see it kind of makes a rapids, and it works. They're also using cannons, which they had up on one of the computers in class the other day, and also trucking these fish around, doing different things, as well as hatcheries, trying to help increase the population. They'll have nurseries in the rivers, and where the babies can grow up to a really good size before, and then they'll truck them around the dam and put them in the river, so that we can maintain wild populations of these fish. This is all done under the protection of the Endangered Species Act. All the monies, all the funding is is available through that for all of this technology that we're using. That's the end of part 3, and we'll begin part 4 with water diversion projects.